Okay, so the topic is the special topic today. It is about exponential function and logarithmic functions. Uh, let's study the two special type of functions: exponential function and logarithmic function. Here, uh, we studied the definition of exponential function, some of its properties, um, and how to graph exponential function. Uh, we will study to find the range and domain of function, intercepts, and asymptotes of the graph. Also, we'll study some transformations, exponential equation, how to solve exponential equation, the number e. We'll study the number e. E is a number between 2 and 3. And then its inverse function, logarithmic function, and changing the logarithmic expression to exponential function. Also, the properties of logarithmic function, and natural and common logarithm, and solving both exponential and logarithmic equations. So these are the topic of study. So in today's lecture, we'll study the basic of exponential functions. And if we have time, then we will go further to logarithmic functions. So let's go to the definition of exponential function. So exponential function is a function of the form fx equals ca to the power x, where a is a positive real number, a is greater than 0, and a is not equal to 0. So the restriction here is a is greater than 0, and keep in mind a is not equal to 0 here. The function value is fx equals c a to the power x, and the constant c is not equal to 0. If x becomes 0, then functional value of 0 would be c times a to the power 0. That will become c times 1 would be c. Yeah. And then let's draw this case of exponential function. For this, you need to make a table. So here in the reference side, pick up some numbers. Let's take 0, -1, -2, -3, -10, -20, whatever, and take positive value and negative value. So you can take real numbers, the set of real numbers, And here the function is 2 to the power x. Take the -10 here, then 2 to the -10, and if you find this value, then it would be approximately equal to 0.00098. And similarly, find the value of 2 to the -3, that would be 1/8. And similarly, find 2 to the power 0, that would be +1. 2 to the power 1 is 2, and 2 to the power q is 8. 2 to the power 10 is 1024. So let's make this case here, x-axis and y-axis, and plot these points. So the first point, take this 0, 1. So 0, 1 is this one, and go to the negative side, -1 and 1/2. So -1 is this one, 1/2 is this one, and go -2 and 1/4. -2, 1/4 is this one, and -3, 1/8 is this one. So go to +1 and 2. This one is the right point, and +2, 4 is this one. So you can go to the point 10, and here 10, 1024. So if you draw a line given by this form line. So this type of curve is known as exponential curve. Exponential curve. So for example, you can take the function f(x) equals 2 to the power x, 3 to the power x. It's not only 2 to the power x, 3 to the power x. It might be less than half or less than 1. That's 1 over 2 to the power x. So this might be 2 to the negative x. So the functional value can be 3 to the negative x. It might be, let's say, take another value. It might be 5 to the negative x. So these are also the function. These are also the exponential function. So if the function is of this form, if the function is f(x) equals a to the power x, where a is greater than 1, then what we did here, this case like this one, the graph is similar to this one. So if a is positive, that means it's greater than 1. So we have restriction. This a is greater than 1, and a lies in between 0 and 1. So if a lies in between 0 and 1, the graph starts from negative side to positive sides. Initially, the graph, the height is bigger, and consequently, we'll see the height become smaller, smaller, smaller. So you see that the x-axis is asymptotic here. X-axis is asymptotic here. X-axis is asymptotic here. So see here, if a is greater than 1, this is like this one. If a lies in between 0 and 1, this case is like this one. Okay. Let's go to next page. So what are the properties of exponential function? So the exponential function is f(x) equals a to the power x, and take, for instance, a is greater than 1. We see that the domain is the set of all real number. In previous page, we see that x takes all the values, negative 10, negative 5, negative 3, negative 2, 0, positive 1, 2, 3, 4, and so on. So it takes all the values. That means the domain is the set of all real numbers. Whereas the range is the set of positive real numbers. You see here, the range is the set of positive real numbers. This is positive here. This is positive here. This is positive, 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 positive. So this is the range. This is the range. So domain is the set of all real numbers, whereas the range is the set of positive real numbers. And there are no x-intercept. The y-intercept is 1. See here, no x-intercept. So here, the x, you can the line, the graph is crossing at 0.0, but you can see this graph, or the curve is crossing to the x-axis. So you can see here, x-intercept, but the y-intercept is equal to 1. The x-axis, y equals 0, is the horizontal asymptote, and f(x) equals x. When a is greater than 1, the function is increasing. You see here, the function is increasing here, and one-to-one function. So how we check the function is one-to-one? If there is horizontal line, this, so if it crosses at 1 point, not more than 1 point, the function is one-to-one. The function is one-to-one here. The graph of f contains the point 0, 1, 0, 1, 1, a, 1, a. You can take a couple of points. That would be enough. The graph of function is smooth, continuous, no corners or gaps. You see here, the graph is continuous. There are no peaks. There are no circles like this one. There are no gaps, and that means there are no gaps. So this is for y equals 3x, y equals ax, y equals 2 to the x, y equals 5 to the x. These all are similar. And let's take the function f(x) equals a to the power x, and that this constant e lies in between 0 and 1. Here also the domain of the set of all real numbers. The range of the set of positive real numbers, the same. There are no x-intercepts, only we have y-intercept, and the y-intercept is equal to 1. The same here. The x-axis, y equals 0, is a horizontal asymptote as the x tends to infinity. The similar is above. Fx equals ax. When a is less than 1 and it is greater than 0, then the function is decreasing function and is 1 to 1. The two functions are 1 to 1. That's right. But this is different here. The function is increasing here. The function is decreasing here. The function is decreasing. You see here, this is increasing function when a is greater than 1 and when a is less than 1. And if a lies in between 0 to 1, then the curve is like this one. The function is decreasing. Function is decreasing like this one. Decreasing. The function is decreasing. The graph of f contains the point 0, 1, 1, a, negative 1, 1 over a, the same. The graph of f is smooth and continuous. There are no gaps. The same as above. So the difference between two functions fx equals a to the power x, where a is greater than 1 and a is less than 1, is that one function is increasing function, another function is decreasing function. That's all. Otherwise, all the properties are more or less similar. So by using transformation that we studied some transformation techniques such as shifting horizontal, shifting vertical, shifting to the left and shifting to the right, vertical up or down. And then there might be some compression or extension. We studied this kind of stuffs in previous classes. So for exponential transformation, you need to understand now that let's say this is a graph here, and this is a decreasing function, and this is a graph here. This is an increasing function. So this the function is y equals a to the power x. The function is y equals a to the power x. And see, what is the difference here? Is this a greater than 1 or less than 1? We studied just now. If it starts from here to here and it is an increasing function, then this a is greater than 1. If it is like this one, if it is a decreasing function, then a is less than 1. So here, 0 is less than a is less than 1. Here, a is greater than 1. So you need to remember these two functions. In this case, the basic case. So if this fundamental functions case are known, then it will be easier for us to plot the graph. This here is greater than 1. Let's take the function fx equals 2 to the negative x minus 3. So first see here 2 to the power x. The fundamental function is 2 to the power x. Or you can take, if it is a negative x, then it's just the reflection here. 2 to the negative x is this one. And negative 3 is here. So we added a negative number. Or we can say you subtract number 3. That means it is shifted vertically downward by 3 units. So here, this is y equals negative 3, and the curve is shifted vertically downwards. Or whatever this one. What about 4x plus 2? For 4x plus 2, the 4x, the curve for 4x, simply for 4x, 4 to the power x. If the curve is y equals 4x, then it is similar to this one. It will be like this one. You can take the values and it passes through 0, 1. This is 0, 1. Passes through 0, 1. And here is plus 2. That means the curve now shifts vertically up by 2 units. That means now the curve becomes this one. And 0, 1 is here. This is 0, 1. If you shift by 2 units, then What would be the value? By 2 units up, plus 2. Here when x equals 0, y equals 4 to the 0, 4 to the power 0 plus 2, 1 plus 2 equals 3. So it passes through, this is 0, 1, it passes through 0, 3. So 2 units up, this is 3, 0, 3. So the curve is like this one, it passes through here, this point. Okay, so here this is x-axis, passes through this one, and the curve is like this one, and here it is x-axis is also the asymptote here. This is x-axis. For 2 to the power x plus 3. You see here, the fundamental graph is this one, fx equals 2 to the power x, and the argument, in argument, you replace x by x plus 3. If x plus 3 is there, then there will be horizontal shift to the left or right. The horizontal shift to the left. Horizontal shift to the left. Okay. So this is the graph here. It passes through 0, 1, 0, 1, because or not. See here, when x equals 0, y equals 2 to the 0 plus 3 to q equals 8. This passes through 0, 1, but this passes through 0, 8. So 0, 8 is here. 0, 8 is here. So it is stripped by 3 units. Or you can find the asymptote here and make a graph like this one. It passes through this one. Whatever negative 3x. So it's similar to this one. Negative, just here 2x. First, this is the graph 3x. Y equals 3 to the power x. Then the graph is like this one. And if negative sign is there, it will be the reflection about x-axis. It will be the reflection about x-axis. The reflection is this side. It passes through 0, 1, but it passes through 0, -1 here. So I try to understand this type of graph. All graphs are based on these two fundamental graphs. Got it? Okay. And what about this one? Fx equals negative e to the negative x minus 2. Fx equals e to the x is right here, e to the power x. This is e to the power x. E to the power x, this passes through 0, 1. E to the x minus 2. So when x equals 0, y equals e to the negative 2. 1 over e squared. This is a positive quantity. So it passes through 0. And keep in mind that e lies in between 2 and 3. The exact value is e equals 2.71 something, yeah? We'll come back to the definition of e. Yeah, later we'll define this type of exponential function in terms of limit. Yeah, this is the problem of calculus. So it passes through 1 e squared. That means 1 over e squared, if you plot it, then the value would be here. It passes through here. That means it will shrink. It will be compressed. So the like this one, and x minus 0 and x minus 2 minus 2. So it's it right. So this is e to the x minus 2. And if you multiply by negative value, then it would be fraction about x-axis. So the reflection of this one is like this one, okay? So what is the value of this one? The point here, negative 1 over u squared. So it passes through 0, negative 1 over e squared. 1 over e squared. So this is the exact set curve. The rule is same for all. The number e is a number of the form this one. If you want, it will be 2. If you write a number like 1 over 10 to the power 1 plus 1 over 10 to the power 10, it will be 2 point something. And take a there are 1, 2, 3, 4, 5, 6. Yeah, let's. You can take any number here. I'm taking 1, 1, 2, 3, 4, 5, 6, 6 zeros. The value would be 2 point something. So ultimately, the value will convert at the point 2.71 and plus 1. This fixed number is known as E. Just remember this, how we define pi. If you take a circle here, this is the diameter of a circle. So make a bigger circle. Let's make a big circle like this one, okay? And then here's the center, and make a center, make a diameter. And measure the circumference. Measure the circumference and find the perimeter of the circumference. Let's say I'll write C, the perimeter of the circumference. Then the circumference distance divided by the diameter distance. D is always a constant ratio. 20/7, 3.14. And mathematician discovered a number that gives the fixed value, and they use the number pi to denote 3.14. This is a constant value. So we define pi is the ratio of circumference divided by the diameter. So similarly here, E is a Euler's number. Sometimes they say exponential number. The number E is defined as 1 plus 1 over n to the power n, when n is a large number, very large number, because this gives the fixed value. This fixed value is E. So E is a number between 2 and 3. So this is equal to 2.71. There might be other number to the power x. This is also special exponential function. Okay. Let's solve the exponential function. So there is a rule. If the base is the same, the power are the same. That means if you have a to the power u equals a to the power v, then u equals v. Same base has the same power. That means power are equal. These are lots of exponents. Let's add some exponents rule. If you have the base same a and the power are s and here t, then the base is the common for both, and you need to add the power. And if you have as to the power t, then it should be ast. If you have base av and power is s, then you need to distribute this a to s to both a and b. So 1 to the power s is always equal to 1. So a to the power negative s is equal to a to the power 1 over a to the power x. And a to the power 0 is always equal to 1. That means something power 100, power 0 is equal to 1. 1 to 2 to the power 0 equals 1. These are certain rules of exponents. Let me solve this problem, this exponential problem. Here you have 4 to the negative x equals 64. So 4 to the negative x can be written as 64. So it is 4 to the power 3, right? So 3, 4 times 4 is 16 times 6 times 4 is 64. So if you have the base same, the power are the same. That means negative x equals 3. If you multiply by negative 1, then x becomes negative 3. So this is the value for this problem. That means the solution for this problem is this one. So what about the second one? 64 to the power 2x. So this can be written as, you can write this 64 is the power of 4. 4 cubed is 64. 2x is equal to 16 is 4 squared to the power x plus 1. So you can write 4 to the power 3 times 2 is 6x equals 4 times 2 times x plus 1. Now here, the base are the same. Base are 4 and 4. So power should be equal. That means here, 6x should be equal to 2 times x plus 1. Divide both side by 2. Then you will get 2 times 6x, 3x equals x plus 1. And subtract 1 on both sides. Subtract x on both sides. Then the value would be 2x equals 1. So x would be 1/2. The value of x is 1/2. So similarly, you can solve the rest of the problem. So for the transformation and graphing exponential function, we can discuss the this next class. I think you can graph the function. You can find the domain of the given function. You can find the range, you can find the intercept and asymptote. Try by your own. In the next class, we will discuss the logarithmic function. Yeah, if you have any problem, you can email me. Yeah. So unfortunately, I can't come in time today in your class. So I'll send you the link of this video and the notes of this class. Thank you and happy Halloween.